Hi, this is Thomas. Welcome back. Our topic is trigonometric identities. This is example number 4. Our requirement reads as follows. Prove the identity sine 3a is an identity with 3 sine a minus 4 sine a cubed. Step 1, identify scenario, equation, or identity. In this example, we're dealing with an identity. Step 2, identify relevant trigonometric identity. Identifying the relevant identity takes some practice. In this case, sine of 3a leads me to the idea that I can work with the compound angle identity for sine and addition. Sine of a plus b is an identity with sine a cosine b plus cosine a sine b. Now in step 3 we substitute. So in our example we're dealing with sine of a plus b will be breaking 3a into 2a plus a, which is an identity with sine of, notice the first angle is 2a, cosine second angle is a, plus cosine 2a sine a. Now I see two additional identities that I can work with. So I'm going to go back to step 2, identify relevant trigonometric identity. As a result of our substitution, we see two double angle identities. Sine 2a is an identity with 2 times sine a, cosine a, and cosine 2a is an identity with, and we have a few different options for an identity for cosine 2a. Notice in our proof that we're working towards sine a cubed, and there's a particular double angle identity for cosine that will be helpful for us. This is cosine a squared minus sine a squared. And again, step 3, substitute. And on the left side, we will go back to sine of 3a is an identity with. Now on the right side, sine 2a, we're going to replace with 2 sine a cosine a. That's coming from the double angle identity for sine, times cosine a plus cosine 2a we're going to replace with cosine a squared minus sine a squared, coming from the double angle identity for cosine, times sine a. And now step 4, simplify to solution, or in our case, desired expression. Sine 3a is an identity with our first term, 2 sine a cosine a will become 2 sine a cosine a squared. Our next term will distribute sine a to get to plus the first term inside the brackets, cosine a squared times sine a, distributing sine a, will give us cosine a squared sine a. The second term in the brackets, minus sine squared a, distributing the sine a outside of the brackets, will give us minus sine a cubed. Now we have 3 terms on the right side of the identity. Notice that we have like terms for the first 2 terms. Both include sine a and cosine a squared. Adding the first 2 terms gives us 3 sine a cosine a squared minus sine a cubed. Notice in our final proof that we're only dealing with the function sine. We want to eliminate cosine a squared. So let's go back again to step 2, identify relevant trigonometric identity. Cosine a squared is an identity with 1 minus sine a squared. And step 3 again. We'll substitute in. Sine 3a is an identity with 3 sine a cosine a squared will become 3 sine a, and replacing cosine a squared with 1 minus sine a squared minus sine a cubed. And once again, step 4, simplify to solution, or in this case, desired expression. Sine 3a is an identity with, we'll distribute 3 sine a. 3 sine a times 1 is 3 sine a. 3 sine a times negative sine squared a is minus 3 sine a cubed minus sine a cubed. And one more simplification on the right-hand side. 3 sine a minus, notice we have like terms, minus 3 sine a cubed minus sine a cubed. Minus 3 minus 1 is minus 4 sine a cubed. This completes our proof, and this concludes Trigonometric Identities Example 4.